Okay, so title your notes, misleading graphs, section 3-7. This is the last section for this chapter. So basically what we're looking at is we're seeing how graphs can be maybe construed in a way that may be a little misleading, that may, if people are looking at the details, you might look at it one way, but that if you look a little closer, you might see something more. So for example, on this one, we've got the 6th grade, 7th grade, and 8th grade, and the money they raised for the United Way. Okay, so which group is the group that's most likely to have prepared the graph? Well, at a quick glance, it looks like the 6th grade did awesome, right? Okay, so most likely the 6th grade made this. And the way they made it misleading is that they didn't start with 0. So they started with 1,000 and then they counted by $250. So here it looks like the 7th grade really hardly raised anything, but if you look at the details a little closer, you can see they at least raised, you know, well, $1,000, maybe halfway between $1,000 and $1,250, okay? It looks like here that the 6th grade versus the 8th grade, it looks like they doubled it, okay? But if you look at the numbers, it's actually, well, it looks like maybe about $2,250 and $1,750. Well, clearly that's not twice that then. This should have been, you know, a lot closer to $4,000 then. So that's one way to make it misleading, is to not start at 0, okay? All right, this graph was a little interesting. You don't see this one too often, but if you look real closely, it says EOG growth per student, and it says, how has whoever made this graph tried to mislead people about the scores? They changed the data. Well, no, they didn't change the data, okay? So it's not that one. They used an inappropriate interval. Well, they counted by ones, and they counted by, no, that's okay. The scale is broken. Nope, everything's intact there, so it's gotta be D. It says the horizontal axis is reversed. Well, yeah, if you look closely, 2004, 2003, 2002, it's not in ascending order, it's in descending order. Well, who makes a graph like that, okay? So they're trying to get you to see that, oh, wow, it looks like it's increasing, but if you look at it, because the time is reversed, your scale is then reversed, so it should be actually decreasing. All right, here's another one. Again, they didn't start with 0. They started with 110 and then counted by 5s. Okay, so we got our bowling averages. So if we had to answer this multiple choice question, okay, it says, which of the following best describes the difference between Emily's and Hildy's average? Okay, Emily's average is about 2 times as high as Hildy's. Well, Emily is here 2 times, well, no. Not even by sight it's not, but even if you look at their scores, definitely not. Emily's average is about 10 points higher than Hildy's. Well, this looks like about 125-ish, 26-ish. This looks like about 114. That could be. It's about 10 points. We'll skip that for a second. Emily's average is much better than Hildy's. Okay, that's not very mathematical, so let's get rid of that one. Hildy's average is about 15 points higher than Emily's. Well, Hildy's isn't more than Emily's, so that definitely can't be that one. So I would say, of your 4 choices, this is probably the best one. All right, which graph is misleading and why? We've got pizza, hot dogs, and hamburgers. Same thing here, listed as our favorite food. Okay, if you look at it real closely, this one starts with a 0, counts by hundreds. This one starts at 950 and starts by 5s. They're both accurate graphs, but this one is misleading because it doesn't start with 0. Okay? If you were to look at this just at a quick glance and you were in charge of ordering the food, you might say, well, geez, I gotta order a ton of hot dogs versus hamburgers. Looks like 1, 2, 3, 4, 5, 6, like 8 times as many. Okay, but if you look at the actual numbers, well, hot dogs versus hamburgers, looks like maybe 970-ish and maybe 990. That's only 20 more hot dogs, okay? So you gotta look closely, okay, at the way things are labeled. All right, here's another one. This one looks like it was maybe done on a computer, so we don't have any labels over here. But you have, I'm assuming these are hours. So this is the amount of time spent at school. Then we have eating, playing outside, watching TV, sleeping, chores, and homework. So it looks like you're not doing any of these, hardly at all, or just a fraction. But if you look at it, your scale starts with 3. Okay, and actually this is inaccurate too, because from 3 to 3.5, isn't the same distance as it is from 3.5 to 4 when they're counting by 0.5. So this is misleading in 2 ways. 1, it doesn't start with 0, and 2, they didn't count consistently. Okay, they didn't space it out evenly. All right, here's another one. Items recalled by couples. So we've got ourselves a double bar graph, so we can compare impromptu to natural for the couple. It's items recalled. Assigned expertise, no assignment, okay. So couple recall is a function of a couple, natural versus impromptu, and assignment, okay. So basically, the way it's misleading, again, is we started with 20 and counted by twos. Okay, so even if you don't know what the graph is about, you can still tell it's misleading in that they started with 20. So it makes it look like this one is way less than this one, even though it's 24 and 31. It's really not all that much different. This one's a really weird graph. Okay, so if you look at it closely, first of all, it's the foreign-born population and percentage of total U.S. population between 1850 and 2000. So we've got our years across the bottom. We've got our millions of people up the side, but then they put these percentages at the top of each column. Okay, so at a quick glance, you're like, okay, well, that kind of makes sense. But then when you throw these percents in there, like these two are fine. They're both 5%, and they look about the same. Okay, but here is 10%, and here is 10%. Okay, so why are they so different? Even though they're both 10%. Well, if you look closely, okay, this one's at 1850, this one's at 2000, and it's millions of people, it's your population. Well, the population in 1850 wasn't what it was in 2000, okay? Obviously, there's going to be a lot more people in the world in 2000 than in 1850. So 10% of the world's population was a smaller number in 1850 than 10% of the population is in 2000. So at first glance, it's written right. You know, you started with 0, you counted by 5s. You know, they didn't label the years across the bottom, but for the most part, it's accurate. But it did get a little confusing just with the percentages. But if you look close at it, it's accurate. Okay, this is a fun little graph. It's on pets. So each animal shape represents 50 people that apparently have dogs, or 50 people that have cats, 50 people have horses, and 50 people have fish. Okay, so at a quick glance, you might think, oh, wild horses is the biggest, boom, that must be the most people that have those pets. Well, no, because each picture represents 50 people. So actually the same number of people own horses that own fish, according to this graph. And it's the cat owners, okay, that are going to be the highest, that are going to have the most people that own cats. Okay, so even though it looks like cats is less than dogs, because they didn't choose the same shape, it's not a consistent view, so we're not able to quickly compare it. You got to look a little closer. All right, here we got some accelerated reader data. Okay, to make a fair graph of the data, what type of graph would be best? Okay, so here's your table, and if we were to display it, okay, this is what we did yesterday. All right, what is the best way to display that data? Okay, well, you could do each one, but it says the best. I would say the best would probably be the line graph. That's going to show your increases and your decreases. So you got 175, 165, 140, 120. Well, it's not going to be a straight line, but it is definitely decreasing. Okay, and then you can see that a little easier maybe in a line graph. Bar graph would be okay. Line graph is better. Okay. Speaking of bar graphs, here we have two bar graphs. We have Democrats, Republicans, and Independents in some type of voting situation. These graphs are actually showing exactly the same thing. If you look closely at it, Democrats was about 62. This says 62. Republicans in the 50s, and then Independents also in the 50s. Okay. It doesn't really tell us what the graph is about. Obviously, this is your political party. Okay, is this millions of people? I don't know. They didn't really say. What kind of title? It would be nice to know what we're talking about. Was this one particular election? Was it overall over 100 years? Was it just in one topic, one issue? This one doesn't have any label here, so they're not even telling us what they're counting by. So we don't know if they started with 0. I'm guessing they didn't. Okay, because here they went up to 54 and here is 62. Well, that's not that far apart. Okay, as you can see here. So clearly they did not start with 0. They started with maybe 50 and then maybe counted by 4s. Okay, this one might be hard to see. I apologize, but it's kind of a neat little graph. Here, I'll go in white here to outline it quick. All right, so this is a graph about time in hours, and then we have temperature up the side. So at a quick glance, it looks like the temperature was all over the place. It went up, it went down, it went way up and way down, way over here. But if you look at your scale over here, this minimum over here, 98 degrees, okay? And the maximum, 104 degrees. So it's only 6 degrees from here to here. If you were to draw this accurately, okay, and actually started at 0 and counted by maybe tens, this graph would look a lot different. Another way it's misleading is they put this little jagged thing in here. That means that they left out data. They started at 9 a.m., okay, and they went to 9 p.m. So they're only showing half the day as well. Okay, and again, this one might be hard to read just because of the small font, but basically what we're looking at, it says more than 98% of all Chevy trucks sold in the last 10 years are still on the road, okay? So up here, yep, that's true, and it's supported in both statements because, in both graphs, because they both have the same numbers. It's the same data. It's just in this one they started with 0 and counted by 20s. But in this one they started at 95 and counted by 1s. Okay, so this is going to be misleading. It makes it look like Chevy versus Ford even is quite a difference. But if you look here, the percentage isn't really that far apart. Even from here all the way down to here, looks like very significantly different. But if you compare this to this, yeah, they're not all that far apart. All right, this one's interesting. It says X marks the spot, factory workers replaced by real estate agents. Interesting statement. All right, so let's see what we're looking at. I'm guessing these are years across the bottom. 99, 2000, 01, 02, 03, 04, 05. Up the side, we have the real estate, number of real estate agents, and then up this side, we have the manufacturing. Okay, so according to the graph, X marks the spot where they intersect, where now all of a sudden there's more factory workers than there are real estate agents. I'm sorry, other way around. Real estate agents are replacing the factory workers. So my real estate agents, okay, so I'm going up, and my factory workers are going down. Okay, but we can see what year this is happening, but at what number? Well, if I go this way, it's 15,750. If I go this way, it's between 1320 and 1360. Okay, so let's look a little closer into it. Well, manufacturing goes from 14,000 up to 18,000, and real estate goes from 1240 up to 1480. Well, this maximum is way less than that minimum. Would they even cross? It's hard to say. They really didn't label it all that well. So this graph is pretty misleading in that it's just very confusing in the way they constructed it. All right, this one is about soda. All right, so here's one where I found that it's the same data presented 3 different ways, okay? So this one says soda soaring. Soda sales in Monroe County skyrocketed in the first 4 months of 1992. All right, so it went down here, went up, but then it boom, way up there, okay? In this one, it says soda up. Soda sales in Monroe County increased 3.26% in the first 4 months of 1992. Yep, that's accurate, and actually it's the same thing as this one, okay? The difference is that this one started at 9% and increased by 1% at each interval. This one started at 0 and then counted by 1% for each line, okay? So both of them, yep, are supported by the statement, but in this way, because they started with 0, okay, and this one started by 9, it's gonna look different, okay? So this one is a lot more steep, makes it look like it's soaring, where here they're focusing on maybe only 3.26%. Same data over here. Here it says soda flat. Soda sales in Monroe County remained flat in the first 4 months of 1992. Again, same data, okay? In this case, they started with 9%, so similar to this one, okay? But then they chose to count only up to, well, they counted up to 15%, but they condensed it, okay? This one is way spread out, okay, for the way they counted, and here they condensed it. And then horizontally, they extended it. So here they squished January to April in just this tiny little area, and here they spread it way out. Well, that's going to take that line, and it's not going to be nearly as steep. Okay, so depending what you're trying to say, I mean, if you're maybe an advocate for nutrition, you know, maybe you're looking at the soda graphs and you want to pick one of these graphs. Okay, let's say you're you're in charge of selling the soda, okay, you might want to say, well, we need to really work on it because, you know, our soda sales are flat. Or you might say, hey, we're doing an awesome job, look at this. Okay, so it depends what you want to say, and it depends who you are and who you're talking to and who you want to persuade. All right, this one says revenue growing. In the last 5 years, revenue has quadrupled. Okay, I guess we could look and see that these are years, but we have nothing labeled over here. Okay, so we don't know if they started with 0. We don't know if it truly did quadruple because they didn't give us any data, they didn't give us any number. That's why this graph would be misleading. All right, so what you should always keep in mind, always ask for the details behind every chart, graph, and statement. Don't get caught up in the glamour, so don't just look at it and be like, ooh, look at that, it's a really steep line, so yeah, they must know what they're talking about, or it must say this, okay? Don't get caught up in emotional appeal, so if you really feel strongly about one versus the other, make sure you're looking at them both equally. A solid business opportunity speaks for itself without glitz and glamour. Things should become clearer as you dig into the details, not get more confusing. Okay? Now this was a couple different ways that we can show that graphs are misleading. We can also look in the book, there's a couple other options in there as well. But basically there's a couple ways that graphs can be misleading.